Standard 5.1, expand, condense, and evaluate expressions using trig sum and difference formulas. Let's take a look at our first example. It says evaluate with exact value, sine of 285. If we think about a sketch and put 285 degrees on our coordinate plane, we see that it lies in the fourth quadrant and it is 75 degrees away from the x-axis. And 75 is not one of our special angles. It's not a 30, a 45, or a 60. And so we don't know the sine of 285 because we can't use our 30 or 45 or 60 values, our note card values. So what we're going to do is take 285 degrees and split it into the sum of two different degree measurements. And we're going to choose these degree measurements so that both of them end up being 30s or 45s or 60s. Excuse me. So noticing that 285 ends in a 5 and 45 is the only angle on our note card that ends in a 5, I'm going to use 45 as one of our angles. And 45 plus what equals 285? That's 240. So we're going to split 285 up into 45 plus 240. Now notice this is really in the form of sine of A plus B. And if we look at our formula sheet, sine of A plus B expands to sine A cosine B plus cosine A sine B. And replacing A with 45 degrees and B with 240 degrees, we get this to be sine of 45 cosine of 240 plus cosine of 45 sine of 240. Now we know all of these values because they are 30s or 45s or 60s. Sine of 45 is root 2 over 2. That's a note card value. 240 is a 60. So if you look at a little sketch here, 240 is a 60 in quadrant 3. Cosine of 60 degrees is 1/2, but because we're in quadrant 3, it's negative. Cosine of 45, note card value, root 2 over 2. Sine of 240 is the sine of 60, which is root 3 over 2, but again, negative because we're in quadrant 3, and sine is negative in quadrant 3. So we evaluate each of these individual trig functions. And now let's do some arithmetic. We can multiply to get negative root 2 over 4. And our other product is negative root 6 over 4. And since we have a common denominator of 4, our answer is negative root 2 plus negative or minus root 6 all over 4. That's the exact value of sine of 285. Let's take a look at another example. Here we're asked to simplify the given expressions. Look at what we have here. If we look at our first example, we have cosine, cosine, plus sine, sine. So if we go to our formula sheet, notice that cosine, cosine, plus sine, sine matches with our cosine of A minus B, cosine, cosine, plus sine, sine. So we can condense to the left side of the expression, identifying A and B. In this particular case, A is 125 and B is 100. And this becomes the cosine of A minus B, or the cosine of 125 minus 100, which is the cosine of 25 degrees. Now let's see if we can simplify further. 25 is not a 30, a 45, or a 60, and we can't create 25 using two note card values. So cosine of 25 is the furthest that we can go in this particular case. Our second example, if we take a look, is in the form sine, cosine, plus cosine, sine. So if we go back to our formula sheet, sine, cosine, plus cosine, sine is this formula circled in green. Notice we have sine, cosine, plus cosine, sine. And that corresponds to the sine of a plus b. So going back to our problem here, this becomes the sine of a plus b, where a and b are pi over 6 and 7 pi over 6. If we add these together, we get sine of 8 pi over 6. And that reduces to 4 pi over 3. Because it's over 3, we know it's a 60. 4 pi over 3 is a 60 in quadrant 3. And so the sine of 60 in quadrant 3 is negative root 3 over 2. So in this particular case, we can simplify because we know the value of that angle. That is standard 5.1 using sum and difference formulas.